Hello friend, today topic is electric potential energy. What is electric potential energy? It is the energy required to assemble a system of charged particles. Means this energy is required to assemble a system. Let Q1 is the charged particle and here Q2 is another charged particle. Both are positive charge particle. They repel each other and but they are placed at this point and this point. It means there is a energy or the force or the work which set them into its respective position. Otherwise, they quit from their positions. Clear? Then electric potential energy means the energy required to assemble a system of charged particles. And how we can calculate it? It can be calculated as the work done required to assemble a system of charged particles. Clear? It is the work done required to a system of charged particles. For example, Q1 is the charged particle here and Q2 is the charged particle here. Both are lying at infinite large separation. Then Q1 is brought from here to its respective position, the work done, and Q2 again brought here from its respective position, that is W2. Then the total work done to assemble a system of charged particle, W is equal to W1 plus W2. This is the total work done and this work done is stored in the form of electric potential energy. Clear? Now, what is electric potential energy? It is the energy required to assemble a system of charged particles and it can be calculated as the total work done required to bring all the charges from infinite large separation to its respective position. This work done is stored in the form of electric potential energy. Clear? Then now we calculate the electric potential energy for a system of two charged particles. Let Q1 and Q2 are the two charged particles separated by a distance r12. Initially, both the charged particles are lying at infinite large separation and we have to bring this charge to its respective position and this charge to its respective position. And the work done in this process and the work done in this process and the total work done W1 plus W. Clear? Then now to bring Q1 charged particle from infinite large separation to its respective position, that is, for example, that is A. W A is equal to 0. Reason, the work done is equal to Q into V. This is charge multiplied by potential. Here, if there is no charge in the system, then the potential of this point is 0. Therefore, the work done is 0. This is first equation. Now, when we bring the charge Q2 to its respective position, then the potential due to Q1 is acting here. So then potential at the point B due to Q1 charge particle. Potential at the point B due to Q1 charge particle. This is V equal to 1 upon 4 pi epsilon 0 Q1 R12. This is equation 2. Now bring now the work done to bring Q2 charge particle to its respective position, that is WB is equal to potential multiplied by charge Q2. Potential is 1 upon 4 pi epsilon 0 Q1 upon R12 into Q2. This is the work done. Now this is equation 3. Now the total work done to assemble a system of charge particle, W equal to WA plus WB, that is 0 plus 1 upon 4 pi epsilon 0 Q1 Q2 R12. Clear? And W equal to 1 upon 4 pi epsilon 0 Q1 Q2 R12. And this work done is stored in the form of electric potential energy. Therefore, the electric potential energy for the system of two charge particles U is equal to 1 upon 4 pi epsilon 0 Q1 Q2 R12. This is the expression for the electric potential energy for a system of two charge particles. Then the next topic is electric potential energy of a system of n charge particles. Let there are n charge particles Q1, Q2, Q3 and so on up to n. And the distance between them, Q1 and Q2 R12, Q2 and Q3 R23, Q1 and Q3 R13, Q1 and Qn R1n, Q3 and Qn R3n, and Q2 and Qn R2n, and so on. Simply, then how we can calculate the electric potential energy of this system of n charge particles? Let work done required to bring Q1 charge particle from infinite arc separation to its respective position. This is the position of Q1. Then initially there is no charge particle in the system. Therefore, the potential at the point Q1 is 0. Therefore, the work done to bring Q1 charge particle from infinite to its respective position is 0. Q1 W1 is equal to 0. Simply, if we bring any of the charge particle which is first, then the work done is 0, because there is no charge particle in the system. Therefore, the potential is 0. Then first particle Q1 is 0. Now the work done required to bring Q2 charge particle to its respective position, that is W2 equal to potential at Q2 due to Q1 multiplied by Q2, that is 1 upon 4 pi epsilon 0 Q1 upon R12 and multiplied by Q2, that is W2 equal to 1 upon 4 pi epsilon 0 Q1 Q2 R12. This is equation 2. Similarly, now bring Q3 charge particle to its respective position. W3 is equal to 1 upon potential at Q3 due to Q1 and Q2 charge particle multiplied by Q3, that is 1 upon 4 pi epsilon 0 Q1 upon R13 plus 1 upon 4 pi epsilon 0 Q2 R23 multiplied by Q3, or W3 is equal to 1 upon 4 pi pi epsilon 0 q1 q3 upon r13 q2 q3 upon r23. This is equation 3. Similarly, for nth particle, then the total work done to assemble a system of charged particle, W equal to W1 plus W2 plus W3 and so on. That is W1 0, W2 1 upon 4 pi epsilon 0, Q1 Q2 R12 plus 1 upon 4 pi epsilon 0, Q1 Q3 R13 plus Q2 Q3 R23 and so on. Now 1 W is equal to 1 upon 4 pi epsilon 0 common, and Q1 Q2 R12 plus Q1 Q3 R13 plus Q2 Q3 R23 and so on. And in general it can be written as sigma I is equal to 1 to n, sigma j is equal to 1 to n, 1 upon 4 pi epsilon 0 half qi qj rij, where I is not equal to 0. This is expression for work done, and this work done is stored in the form of potential energy. Therefore, U is equal to half 1 upon 4 pi epsilon 0 sigma I is equal to 1 to n, sigma j is equal to 1 to n, qi qj rij, I is not equal to j. This is the expression which is very important for numerical problems. Next topic is equipotential surface. Then what is equipotential surface? The surface at which all the points having the same potential is called equipotential surface. That is equipotential means all the points having the same potential on a surface is called equipotential surface. Then what are the properties of equipotential surface? First, no work done in moving a test charge from one point to another point on the equipotential surface. Reason, W, we know that B minus BA is equal to WAB upon Q naught, but potential is same. BA is equal to BB, then WAB upon Q naught is equal to 0 or WAB is equal to 0. Clear? Then the second property, the electric field is always perpendicular to the element dl of the equipotential surface. Reason, we know that E dot dl is equal to WAB upon Q naught, but the work done is 0. Then E dot dl is equal to 0. E dl cos theta or cos 90 is equal to 0. Reason, E is not 0, dl is not 0, that is cos theta is 0, that is theta is 90. Then E perpendicular to dl. The angle between E and dl is 90. Clear? Third, equipotential surfaces indicates the region of strong and the weak electric field. Strong and weak electric field means E is equal to, we know that E is equal to minus dV over dr, dr is equal to minus dV upon E. But if surface is equipotential, so change in potential is same. So if E is large, then dr will be small because dr is inversely proportional to E. And the next, two equipotential surfaces cannot intersect each other. That is, two equipotential surfaces intersect, then at the point of intersection there will be two values of electric potential. This is not possible at all. Clear? Thank you. Subscribe my channel, and if any doubt, write in comment box. Clear? Thank you.